Okay, this worked example, we're doing the first of the grouped type data. So we've got a fair bit more data and it goes over a higher range. So we've got a sample of 40 people that were surveyed regarding the number of hours per week watching television. Wow, it's not Canamble, there'd be a lot higher numbers there. The results are listed below. Okay. Couple of things. Check, make sure how many people were surveyed. They say 40. Do we agree? Survey says yes. 4 by 10 rows. Cool. 4 rows by 10 columns, sorry. Okay, now, part A. They won't often do this in questions, but they have here. It says organise the data into 5 class intervals and use them to create a frequency distribution table that displays the class intervals, class centres and frequencies. Okay? So all of a sudden, they've told us what columns to use. Class intervals, class centres, frequencies. Happy with that? Okay, so how are you going to work out what the classes are going to be?
Take the range.
What's your lowest?
Looks like it's 6.
5.
4. 5. Yeah.
5? What's your highest?
27.
29.
Yeah.
Jeez, Barry.
I was out by 1.
2.
The first one I was out by 1.
Oh, that helps. So technically you were out by 3 in total.
Yep.
All right, great. Okay, so that's your sort of range, right? Even if it's not, you can always deal with that. Now, we've got that. What sort of data have we got here?
Cumulative.
We haven't got cumulative data yet. We're going to have cumulative. But what sort of data? Don't forget, what are the types of data you can have? 2 Qs.
Quantitative.
Quantitative and qualitative. Okay? Which one have we got here?
Quantitative.
Why?
Because it's a group of people surveyed.
It's numbers.
Numbers. Quantitative, quantity, numbers. Okay? So we've got quantitative data. Awesome. Now, there's a couple of different types of quantitative data. What are they? They are numbers. It's 2 types.
Positive, negative.
One starts with C and one starts with D.
You can't hold this, it's not really this. It's a big number.
Alright. If I wanted to know the average amount of cars per family in Canamble, give me an example of some of the data I might get back. Like what's one of the, if I surveyed families, how many cars you got in your family?
4.
Okay, how many you got?
5.
How many?
2.
Okay, I got 2. Okay. How come none of us said 4.5?
This is no such.
Brilliant, you can't have half a car. Sorry?
Complete.
No, this one's the D one.
Discrete.
Thank you. Discrete data. Discrete data means you can't have halves and stuff like that. Okay? If I was asking for your age, then we deal with it in a discrete manner most of the time. Okay? We ask how many years you are. Okay? Even though it's not technically discrete, you can actually do it in a different way, but we deal with it discrete. What if I was asking for your height?
Specific number.
This is the one that starts with a C. How tall are you?
I'm 175.
175. Exactly 175?
No,
Okay.
a few mils.
Okay, so 175.2. And tomorrow you could be 175.3. And so if I was graphing your height over time, I could draw a line, couldn't I? Yeah, because reasonable expectation is you grew at a steady rate. I mean, it goes like that. It's never going to be perfect, but for the purposes of our exercise, we could say that your growth is
Exponential.
well, no, not exponential. That means you're going up like that. You're not getting double the height every day. That's exponential. That's where you're squaring or cubing. But what is it when something...
Consistent.
Oh, so close. Goes from there, goes to there, doesn't stop in between. It is
Constant.
close.
I can't pronounce it.
Con is correct.
Continuous.
Thank you. Continuous. God, Perry got 2 things right. What are you guys doing?
Oh, it's
Okay.
out by 3, but I've got 2.
Yes,
You
well
got the
done.
numbers wrong.
You're on your way
it
back.
says things.
Okay, continuous data. Okay, continuous data means you can have pretty much anything in between. Does that make sense?
Yes.
Your height can be anywhere in between 0 and whatever. Okay, anywhere. It's up to us to decide how accurate we go, how many decimal places, how many inches, centimetres, whatever. Okay, that's totally up to us. That's continuous data. Cool? We are looking at the number of hours spent per week watching television. Is this continuous or is this discrete? We know it's quantitative because there's numbers involved.
Discrete.
Okay, discrete. Is it?
Yes.
Why?
There's no half, like 12 and a half hours.
There
Yes,
could
you can.
be.
You can do
You can,
1.5
but
hours,
it's been
1 hour,
rounded.
15 minutes.
Does it matter?
No. But it's not
The
continuous.
fact that it can be continuous means we're going to deal with it as continuous. What's the easiest way to deal with it as continuous?
Number, order.
No, we're definitely going to do it in order. Easiest way to deal with it continuous. Well, when we do our classes, see how up there I've got 0 to 10? Okay.
You go to class center.
Yeah, but why don't I do, like I said on over there, less than 10?
These are what's
That way it doesn't equal 10. Because you remember how I was saying 0 to 9 down here?
Yep.
But then if I go to the next one, 10 to 19, what happens to 9.5 hours? It doesn't exist. There is nowhere for 9.5 hours. Does that make sense? Okay, 0 to 9 and then 10 to 19, it doesn't exist. The 9.5, you can't get 9.5, which is fine if you're dealing with the amount of cars. Okay, but it's not fine if you're dealing with something that can be 9.5 or 9 1/4 or 9 1/16. Make sense? So what we do is we use the less than symbol. Okay, so we're going to work out our 5 groupings. Now it goes from 5 to 29. So if we use the ones they suggest, which is 5 to less than 10, that's one grouping. What would the next one be?
10 less than 15.
Excellent. 10 to less than 15. Notice how we're now able to use 10 twice? Because that's not actually 10, that's less than 10. 9 point, no, 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 no. Cool. Then what? What's your third one?
15, what, less than 20.
Cool.
20 less than 25. And then 25 plus.
Nah. 25 to less than 30.
30.
We don't do 25 plus because what happens if someone comes back and says they did 32? They're going to be included in that thing and it's going to skew it. Okay? Alright. Now, we got told what ones to do. We got class intervals, class centers, and frequency. These ones that we've just done in orange, they're your intervals. Okay? So chuck them in. Did I miss one? Oh, I suppose 0 to...
No, it's not.
No, that's 5. Yeah, we only wanted 5, didn't we? That's the sum down there. Just remember, that's not a minus sign that we're putting in there, it's 2. It's like a range. It's not a minus, it's more a hyphen than anything else. So if an English teacher ever listens to this, ah, it's not a hyphen, it's an M dash or an N dash. Yeah, stop being a typographer, that's my job. All right, class centers. Class center, we just find the average. Okay, so this one, 15, 7.5. Okay, next one, 25, 12.5. And you'll notice it goes up by 5.
It's not complex.
It is not complex at all. Complex numbers are much more fun. We'll finish this one before we
Yeah, I
disappear.
was going to say, we're not really going to do it at once.
No. Other classes have a tendency when they hear the bell, they think, hey, we can go. Bell doesn't dismiss you, I dismiss you.
Bill still attention classes, right? Wrap it up.
Yeah, it tells me where you should be, that you should probably be thinking about heading to your next classroom. Of course, the next teacher goes, no, you should send you straight away. And I normally do, because I actually don't like any of you, but that's right. All right, frequency. Have you done the frequencies yet?
Yeah, the F in the brackets is missing.
Sorry, on this one? Feel better now?
Yeah, there.
Alright, cool. Any done your frequencies yet? I'm third and lazy, I don't want to do it.
9, 7, 10, 8, 6.
9, 7, 10, 8, 6. Now, remember how many there were? There's 40. Let's double check. 16, 26, 34, 40. Excellent. They've even got sum of frequency. You know that sigma, capital sigma,
Yep.
is sum. Right? Sum of frequency equals 40. Cool? So we know we've got the right stuff. Everyone happy with that? Alright. Next bit, you have to then graph it. Okay, so you've got to use leave a half unit or a full interval space. Draw in the first column so that it starts and finishes halfway between. Now, have you got it on yours? Can you see what you need to do? Notice how it doesn't have any gaps. Yes. Is it? No, it's not a cumulative frequency. This is a frequency one. This is not a bar graph. Okay. The difference between this and the one we did a minute ago, this is not a bar graph. This is a cumulative frequency histogram. Okay?
Because of the line that goes through it.
That's the polygon. Okay? Cumulative frequency histogram sits nicely together so that the polygon works. Okay? Sorry, not a cumulative. Did I say cumulative frequency?
Yes.
Sorry, I shouldn't have. This is just a frequency histogram. Sorry. With a polygon. A cumulative frequency histogram will have an ogive, which is similar to the polygon but a little bit different. But this is not a bar graph. It is not a column graph. This is a frequency histogram. Okay? So now we actually start putting them together. What was the class center for 7.5? What was my value? 9 was it? Okay. For 12.5, what was it? 7. Okay, can I just show you what I'm doing, the way I sort of do these? Okay, just because this is the way I do it. What was the next one? 17.5? What was the
8.
8?
17 and a half,
10 was it?
Yeah.
Next one?
8. And then 6.
8 and then 6. Notice how I've just drawn the tops of them?
And then you just draw the line.
That's just the way I do it, because then I can just draw the lines up and I know where they've got to go. Like I said before, you don't have to do it this way. It's just the way I do it, and I can just do it like that. Cool?
Very appreciative.
I find it easier. Okay, now the next thing, and I'm going to run out of time here, we've got to mark the midpoints at the top. This is so that we can do our polygon. Okay, so we mark the midpoints at the top of each one. Now if you're using graph paper, it'll already have the midpoint, like if you're using the graph paper and the grid paper. And seriously, if you're going to be doing this topic, I would recommend just printing out graph paper or grid paper from freegraphpaper.com. Just saying. It makes graphing a lot easier because you don't have to measure everything. It's already got the markings. Okay? Okay, then all we're doing is we're going to mark the midpoints and we're going to join them. Okay? So join them with straight lines. Cool? Everyone happy with that?
Yep.
This is your polygon. Now, a polygon is a closed-in figure. This is not closed in. How do we close it in?
0 with the point off at 27. Yeah, 30.
That one should have finished there, so I can go to there. We now have a polygon that's closed in. Happy with that? Awesome. 14 minutes and 20 seconds. That's a long one.